Hey guys, so in this tutorial I'll explain to you how you can use assets and how you can upload those to our cloud services. Assets allow you to import GLB files to your projects and expose those in your small scripts, games, simulations, or whatever you want to do with BitByBit. And today we'll use this Alien Nebula Cruiser demo or concept model that we've created. I've exported it already to GLTF file, so to GLB. It was created by using our read editor, so not TypeScript. It is perfectly possible to create it in TypeScript as well. If you open it, you'll see how it looks like. So in read.js, you create these sort of parametric relationships between various algorithms, and we use all kinds of methods that you also have in TypeScript. So we expose those through those blocks. You see that these are just familiar things. We have shapes and wires and whatnot. So this just works as TypeScript. It just has this nice looking linear flow and it's a bit simpler to code. Let's just click run. Let's look how that model looks like. We have created 3 variations of this model that are looking a bit different maybe than this one. So this is the variant 1, and we'll have 2 more variants that we'll be importing. So I already exported this model. This script allows me to do that. I will not go into details how this works here, but basically have in mind that we have now 3 GLB files. And what I'll do, I'll just go to my projects. I will create a new project. I'll call it demo Alien Nebula assets project. So this is just for tutorial. I'll be deleting it later. I'll submit. I want to create it. You see that this project by default is private. And I'll go ahead and first I'll create a script. I'll just name it demo script for assets. It's going to be TypeScript. We'll just use again some things from Babylon. And what we also want to do, we want to import the assets to this project. So we hit this add asset button. We call it Alien Nebula Cruiser variant 1. And I'll choose the file. I'll submit. It will upload the file. It takes a while. And now we will go ahead. It takes sometimes a bit of time for those assets to appear because the cloud needs to process them. But when it's done, when the upload is ready, you see them here. I want to add another asset. Let's call it variant 2. Let's hit submit. Wait a bit. And last variant that we want is the 3rd variant. So variant 3, choose file, and let's hit submit again. So it's uploading, and when it's done, we're being redirected. And we have now the script. We have 3 asset files, and we'll hit this button to launch the script editor. And we can now start coding, right? So this is a TypeScript editor. It's empty. Nothing was coded yet. And I'll just start the way we started all of our tutorials. I'll just create the start function. I'll say that it's asynchronous. It's an arrow function. And we'll call start on it. So what we'll do now is we will create a constant called files. And it will just hold an array of file names that we have imported. So Alien Nebula Cruiser 1.glb, 2.glb, and 3.glb. So these are all the files that we've imported. What I want to do now is I want to just get these assets as files into TypeScript. And to do that, we'll use some convenience methods from BitByBit that just make this a lot more simpler. And I'll just say that we have these asset files that we'll be getting, and we'll be awaiting on the promise array. So I'll do that. If you're a BabylonJS developer, probably know all this, how this works. So I'm not gonna go into detail and explain it. Let's just go and say that we map the files, and the file name will be the input, and we'll call bitbybit asset get file, and we'll use the file name as a property that goes inside of it. So this should get us the asset files. The only thing that we still miss is Babylon needs to interpret those files as well. And to do that, we'll go ahead and just do constant meshes. This is what we will be getting from this part. So we'll also use the promise .all, and we'll say that for asset files, we want to map asset file, and we'll use bitbybit babylon io load asset into scene method, and we'll go ahead and use asset file with hidden property as false. So we don't want these files to be hidden when we load them. We just want them to appear on the screen immediately. And let's just hit run and see what happens. So now if you click swap canvas, you'll see that all of our assets were imported. They were imported correctly. The only problem is that they are now overlapping. They're all imported in one location. So we'll have to separate them. And we have 3 asset files. So what I want to do is I want to create a triangle. I want to read the corners of those triangle and put these geometries on those corners. And this is quite simple to do. We'll use some bit-by-bit methods to do it. And let's just go ahead and say that we are creating a triangle. So triangle, and we'll use again bit-by-bit ost shapes.wire create n-gon wire. So triangle is an n-gon that has 3 corners, a radius of 14. We'll use direction on 0, 1, 0. Center will be on 0, 0, 0. And that's it. Now we have this triangle. So we can go ahead and visualize it. So let's use bit-by-bit or draw any async with an entity of a triangle. Let's hit run. You see that we've created a triangle, but we still need to get these corners of a triangle. And to do that, we can use a method on bit-by-bit that is gonna give us corners. And the method itself is called bit-by-bit ost shapes edge get corner points of edges for shape. So this will just give us the corner points that are unique, and we'll use the shape of a triangle. And now if all is okay, we'll get this array of 0.3 entities inside of it. And what we can also do is we can visualize those points to just check that they are correct. Let's hit run. And now you see that these are the points. They are all red. Okay, so far so good. Now we have 3 meshes and 3 corners, right? So what we can do is we can go ahead and iterate through these corners. So for each corner, we'll say that we have a corner. And actually we also need an index to get the meshes, and mesh that we want to update is going to be coming from meshes index. And if that mesh exists, there's a slight chance that it won't, right? But let's just be protective. Let's say that the mesh dot position is a new Babylon vector, because this mesh is a Babylon mesh, right? What this method gives us, load asset into scene, is a mesh. So that's quite important to realize. And we'll do vector 3. And the vector 3 will be coming from corner 0, corner 1, and corner 2. This is due to the fact that bit-by-bit just encodes vectors as number arrays. And okay, so now we'll go ahead and click run. And you see that this script begins to be more presentation-like. Our geometries were placed on those triangle corners. And this is exactly what I want, but This script is supposed to serve as a presentation of these models, and what I want to do is I want to make it a bit more fancy. I want to create a triangle base on which these geometries will stand, and let's just go ahead and do that. So let's go ahead and create another triangle for the base. It's going to be a little bit bigger. I'll just copy paste this code, and I'll make the radius of this 30. The rest stays the same, except for the center will be a bit lower because we want it to serve as a ground, and these geometries, you see that they go a bit below the ground. So now we have this triangle base, and we will just visualize it. And I'll delete these ones. We don't need them anymore. These were just used to put the meshes into right positions. So this is the triangle that will serve as a base, but we also want to offset it a little. So we'll create the triangle offset. Offset will automatically round the edges a little, so it will be also slightly larger. And you can do it in many ways in bit by bit. You can just fillet the corners of the wire if you want to, but we'll just do it with the offset. So we'll use operations, offset, and we'll see that the distance that we want to offset is 5. The shape that we want to offset is triangle base. Let's always put the shape first, just to know what we're doing. And the tolerance will be 0.1. We don't need to be exact here at all. So let's do it like this. And we also want to, let's just visualize this, So let's say that we want to visualize the offset. The offset covers more area. That looks quite nice, so I like it. Let's do more things for this triangle. Let's create a face. So let's call triangle face, await, bit by bit, OST shapes, face, create from wire. And we'll use the wire of a triangle offset. And we'll say that it's planar, because it is planar, right? And it will never be non-planar or whatever. So let's create the face. We can visualize it. So because the backface culling is on, it's transparent. This part of the face is occluded. And let's go ahead and extrude this triangle. So let's create a triangle extrusion. This will also be done through bit by bit, OST, operations, extrude. We'll see that we'll extrude the triangle face. And you have to extrude the face and not the wire, because wire will just give you walls and not the solid, right? So it will give you a shell. And what we want to say is that the direction of the extrusion will be 0, 1, 0. And it's just going to give us a triangle base of the height 1. And we can visualize it. Let's hit run. And you see that now we have a nice looking base. But I'm not yet satisfied with it. I want to also make it a bit more futuristic by rounding the corners. So triangle fillet is await, bit by bit, OST, fillets, fillet edges of a shape, triangle extrusion. Now let's use the radius of 0.4. This is going to give us a nice looking base geometry. Yeah, so you see that now the corners are rounded, and what we will do is we'll use some options to draw this geometry. And we need to use OST shape options. We'll instantiate the class. Draw options. We'll use face color, that will be black. And we'll use the draw options triangle edge color, which will be purple. And let's go ahead and pass these options into the method. Let's hit run again. Yeah, I mixed it up. So the edge color needs to be black. and the face color needs to be purple. I'll do it like that. So now we're back to where I want it to be. And while this looks much better already, we located these GLTF files into right positions. But what I want to do as well, I want to create light, and I'll do it via BitByBit's helper method that allows me to create directional light. Underwater it uses Babylon as well, but let's just do it like this. Create directional light. And yeah, let's just create the options like this. And what I want to change is the direction, which will be going towards -100, -100, -100. Light options. Shadow generator map size. So if you create lights via BitByBit, the shadow generator will be created automatically so that you see better the effects of a light. That's why we give this property to the user to already tune up the shadow generator a little. And light options intensity will be 4. These are all the things that I wanted to configure on the light. Let's give it as an input and let's run the code. So you see now that it looks much better. The objects pop. They are more readable as well. I like that a lot. And yeah, geometries are just looking very futuristic. That's quite nice. And now what we want to still do, or what I want to do, is, well, this looks great. It's very much static. And BabylonJS is a game engine. It allows us to animate things, create more interactive scenes. So for this tutorial, I'll just make a very simple thing. I'll just create a rotation animations for these geometries. And to do that, I'll first create a parent mesh. I'll do it via the Babylon mesh method. I give it a name of a parent. And what I will do is we have meshes that we've imported. So for each mesh, I'll assign the parent to be the parent mesh. And for the triangle, what I'll do is we have to await on this method. So triangle base mesh is await the draw. You see that this gives you a mesh. Triangle base mesh will also get the parent of a parent mesh. This will allow us to rotate the parent, and the children will rotate together with it. And let's do that. So let's do BitByBit time register render function. There are more ways to do that, but this one is most convenient, I think, at least for me. In BitByBit, you can just register this function and it will be taken into account in rendering. Okay, so now what we want to do is we want to create a rotation vector. So I'll call it like this. Rotation vector is new Babylon vector 3 0 1 0. So it's gonna be pointing upwards. And let's create the rotation. Let's do it differently. Okay, so now what we can do is we can say to the parent mesh, rotate around rotation vector 0.001. This is going to be a really small amount of rotation, but let's just hit run and see what happens. So you see now that without me doing any rotations in the camera, I can just look how this demo plays out. And this is quite nice. You can record this if you want to with a screen recorder, put it online. It's much more nicer. You can also still navigate this, right? You can position your cameras the way you want it. And yeah, the scene just updates automatically. The game engine is doing its job in the render loop. And you can do more things. You can even go ahead and say that you also want each mesh to rotate on the parent. So meshes for each mesh, apply rotation as well. So rotation vector. And you can say maybe you want to rotate a bit faster on this direction. Maybe you want to rotate a bit slower with the parent, for example. Let's hit run. And you see now that this is even more interesting, right? So your children are spinning and your base is spinning together with those. So this is quite cool, I think. And if you agree, just use BitByBit, upload your own assets, animate things, play around, make them presentable. Okay guys, so I hope this video was helpful to you and you've learned how to use assets with BitByBit, how to upload them, how to import them in your Babylon projects, and how to animate things even. So this is, everything you need to know to start and import your own models. You can create models with BitByBit if you want to. You can also create them in other applications. And yeah, just try it out. And I hope you enjoyed the video. Let's see each other in the next ones. Cheers, guys.